So this is your first video that goes along with your notes. And so what you have in front of you is in your note packet, you should have a worksheet that looks about like this. That says Conservation of Mass. Now this video is going to go along with this Conservation of Mass worksheet. Eventually, I'll just be posting videos and you'll be taking notes in your notebook or just on blank pieces of paper and attaching it to your packets. But we're going to kind of ease you into it. This is in lieu of having long lectures in class. We'll have lectures here, you'll watch them at night or at the very beginning of class, and then we'll get to doing more labs and activities during class and more practice in class when you have myself and your classmates to ask questions to and you can work together, as opposed to being at home and lost on your own. So what we're going to do is we're going to go through the information of the video first, and then we'll go through some example problems and then practice problems. So I'll tell you about the information and the vocabulary and whatnot that you need to know, the content. Then we'll practice together, and then I'll say, okay, practice this one. You'll practice it on your own. We'll check to make sure you have the same answers. And then the next day in class, what we'll do is we'll go over those answers together, go over any questions you have. So it's really important that you watch these videos when they are assigned. That way you can come to class with questions and you know what's going on, because we're just going to keep moving right along forward. So without further ado, we have the conservation of mass, and which states that the law of conservation of mass in any physical change or chemical reaction, that mass is going to be conserved. Now what does it mean for mass to be conserved? Well, mass can neither be created or destroyed. So the mass of the reactants has to equal the mass of the products. That means we can't just make up mass from anything we want to. We can't just create it for ourselves. It has to come from somewhere. So we have our first example problem. Example number 1 states that hydrogen and oxygen react chemically to form water. How much water would form if 4.8 grams of hydrogen reacted with 38.4 grams of oxygen? So first I write down the information given to me. I'm told I have 4.8 grams of hydrogen that are reacting with 38.4 grams of oxygen to make water, which is H2O. I know from the law of conservation of mass that my reactants has to equal my products. Therefore, 4.8 grams plus 38.4 grams of my reactants, my H2 and O2, has to equal my products of 43.2 grams of water. So since my mass of my reactants equal my mass of my products, this proves that the law of conservation of mass is true. And you'll eventually do a lab on it as well. Example number 2. When ammonium nitrate, NH4NO3, explodes, the products are nitrogen, oxygen, and water. When 40 grams of ammonium nitrate explodes, 14 grams of nitrogen and 8 grams of oxygen form. How many grams of water form? So this is the chemical equation, and we'll learn more about this in later units. But I have ammonium nitrate breaks down into nitrogen, oxygen, and water. Now the law of conservation of mass states that my reactants mass has to equal the mass of my products. So my mass of my reactants, because it's being broken down, is my ammonia, my 40 grams, has to equal the sum of my mass of my products, 14 grams of nitrogen, 8 grams of oxygen, plus so many grams of water. Now to find this, I subtract 14 and 8 from both sides of my equation to get rid of them on the right. And when I do that, I get 18 grams of water as my final answer. So that means not only does it break down into 14 grams of nitrogen, 8 grams of oxygen, but also 18 grams of water. Okay, now comes the part where you're going to try. So on example number 3, it'll be the last one there. You're going to attempt the problem, and then you'll check your answer here. So you try number 3, and you should get an answer of 6.4 grams of sodium chloride.